anticipating temperatures in the mid to low 80s today. That's where we were on Thursday and Wednesday. We can
Hey guys, we're back for another segment of Parallel Rack and Supermarket Refrigeration. Let's go over the electrical a little bit. Starting at the beginning, our main breaker. Now this breaker controls everything in this rack. And if we look, we can see our voltage coming in. It's 202.9 volts from L1 to L2, L2 to L3, it's 202, and L1 to L3. It's 202. When you're checking electrical power on a three-phase system, you want to make sure you control everything. And so if I was to kill a power to this rack, it's going to shut everything down. And if there's something that I need to work on electrically, I can do it by killing that power. Now, this power has feeds just about everything in here that has breakers. So each contactor has its own breaker. Power's coming from our main breaker. Same here and same there. We have 3 contactors and 3 breakers. Actually, there's 6 because we have control breakers on here also. After that, we have what we call a phase monitor. Our phase monitor does exactly what it says. It monitors the phases. We have 3 phases coming here. That's what I call a 3-phase system, 1, 2, and 3. So if either of these lines lose voltage, it's going to shut the rack down. So if I have low voltage here, or if one of those fuses blows, or if I lose something there, it'll shut the rack down as a phase loss. Because believe it or not, guys, sometimes that happens. Power companies aren't 100% reliable. You never know when a traffic accident is going to knock power, and it may just only kill one line. A 3-phase motor will burn the hell up if it tries to run without all 3 phases. It's going to try to run, and you want something to protect that motor. This motor here, about $5,000 plus the install. It's very expensive. We want to protect that piece of equipment when we use the phase monitors to do that. After the phase monitor, we have our condenser breaker. So if I want to work on the condenser for whatever reason, I can simply shut the breaker off there, go around the other side of the panel. Some of the older ones had contactors in them that you'd have to replace. You want to kill the power because you don't want to get lit up with electricity. It hurts. We've all been there if you're in the field. Don't get electrocuted. So we have breakers to kill the power to that. This particular one, there aren't any contactors. It's just a board that increases and decreases the speed of the fans. So in order to do anything over there, for either one of the fans, you need to kill the condenser fan breaker. The power also supplies voltage to our E2 controller. This is mama. This is the heart. This is it. She's controlling this rack. Anything that happens on this rack is because of her. Now, remember what I was talking about earlier with the information on sensors and stuff. She's only going to work with whatever information she's given you. So if she's lied to you, she's going to put out false information because she's getting false information. So she does that by boards. We have what we call input boards and output boards. On this particular rack, we have a couple input boards. All these wires, those are just sensor wires. Those are just wires that are looking at case sensors and looking at transducers. The transducers will convert the suction pressure to a number so that you can read it on the E2. That's all that is. That's information in, input board, information in. We have the output boards, information out. So when the E2 mama over there, when she gets information here, she says, she takes that information, decides, oh, what am I going to do with this information? You want defrost right now because you programmed me to go and defrost at 2 o'clock? I'll give you defrost at 2 o'clock. And she's going to send information out to these boards, a bunch of relays. We call it an 8RO because there's 8 relay and it's an output board. And she's going to say, open or close that relay and energize or de-energize that valve for defrost. That's how a 16AI works. Input board, taking information, giving to mom, output board. I'm going to take that information, I'm going to send it out, and you're going to do something with it. Input, output board. We also have ESR 8 board. We have almost 24 volts powering up that board, coming off of that transformer. Anyway, ESR board, that is evaporator suction regulator board. So it's that's what's controlling our CDS valve. So when she says, I want 8% valve, she sends a signal to this, and this starts closing this valve or opening this valve as needed. There are so many different applications. We have Einstein boards. We have CCD boards, which are case control board. We have XM boards. So just all kinds of different things we can do with different applications, depending on what you need. Another board is what we call a multiplex board. It's kind of a combo board. It's an input board and an output board stacked on top of it. So this is what we call a space saver. It's a multiplex board. Instead of, like you saw earlier, 2 big boards, we have one board that can do it all right there. This analog output is sending a signal to our unloader. It's just a digital unloader for that compressor right here. Basically, it's energizing and de-energizing. Instead of turning that contactor on and off 100 times, it's just going to unload the heads on that so that it's just a motor running. So there's nothing else happening. It's not doing any work inside that. That's a whole different segment. When you're diagnosing stuff, you want to have your handy meter. I like to use the Fluke 3000. Some people use the Fluke 902. Some people use UEI, EUI, UI. I don't like them, so I don't remember the name of them. Some people like the, what's that other yellow one? Field piece. A lot of people like the field piece. I grew up on Fluke. I like Fluke. I trust Fluke. I use Fluke. You don't have to, though. Just use a good meter that you trust. You don't want to put a meter on there. Speaking of meters, have a good set of meter leads. There's nothing worse than going to a job site and you got nicks in your meter leads and you're leaning up against it or something. You touch electrical and you get shocked. Or it's cut and you don't know it and you're reading the wrong voltage. High voltage is very dangerous and you don't want to die doing anything for a job. No job is worth dying for. So please, 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 I can't stress enough, use proper equipment when you're working on this stuff. Take your proper safety measures. Use good meters with good leads. You can buy a set of leads for 20 bucks or so. So we do have different components on a compressor safety. We have an oil pressure sensor. So if I lose oil pressure on this motor, it'll trip out. It senses it through this sensor here. We have a high pressure sensor. So if my pressure gets above a certain pressure on this particular rack, we got them set for 350. It's going to shut the power off to the contactors. It's all wired in series. That's wired in series with that. So either one of those fail, it's going to shut this off. So that's the basic rundown of the electrical system in a parallel rack. This one's a fairly simple one. There are more that are complicated, but you don't want to get in that unless you have hands-on experience with them. Hopefully I got all the basic components of this rack. Like I said, anytime you want to work on things, you're not sure, oh shit, I just killed the rack. We better start that back up. Kill your main, work on it, get it back and running, because right now they have no refrigeration going to those cases. Stay safe, guys. Go out there, learn a little bit about parallel racks. Thanks. That sucked that didn't come back on.